I know some of you may not want to admit you have played a Sims game. That's okay. All right, for the folks who haven't played a Sims game, Sims is a life simulation game where the players get to control and create the characters that we call Sims. This is an in-game scene from Sims 4. Sims is one of the most successful PC game franchises of all time. We have over 20 million people following us on social channels. And it has been around for a while. We just celebrated our 15-year anniversary just last month. In a Sims game, the characters play an important element. And their physical appearance plays a big role in bringing out the personality of a Sim alongside how they behave during gameplay. This is an evolution of our characters starting from Sims 1. And you can see that in Sims 4 we went with less realism and more stylized look, providing for greater scalability and opening up for more possibilities. So it is easy to see that character customization plays an important part in Sims games. And we have tried to push the envelope on character customization with every version of the Sims game, and Sims 4 is not different. And I'll share with you some of the new features we introduced and some of the techniques we used to achieve it in Sims 4 Character Creator that we call Create a Sim. Let's roll a short video that demonstrates some of the features in Sims 4 Creator Sim. A little bit of volume, please. Cool. So a few weeks before the main game came out, we released a free product, this Create a Sim product that lets players create their Sims, create a household, upload to an online gallery, share with others, and download to the main game. It's a free download, so you're welcome to try it out. So in this talk, I'll go over some of the core elements and goals that we set out to achieve for Sims 4 Character Creator, and how we achieved it using different techniques that I'll dig into more details. And hopefully we have time for Q&A at the end. I know this is pretty tight for covering a lot of the details, but if you don't cover a lot of things in the Q&A, I'm available to talk after. Also, disclaimer: this is not a full feature set or all the innovations in Sims 4 Character Creator. It's just a handpicked items that I thought was worth sharing with you guys. All right, so going into the creation of Sims 4 Character Creator, we had two main goals. First, we wanted to give a toy-like experience, make it accessible and fun, and also provide for a lot of customizability. And you can see that if not careful, these two elements can be opposing to each other. You introduce a lot of features, and they become hard to use and less accessible. So to make the experience more accessible and fun, we focused on a few elements. Minimalist UI, that's not foreign to you guys, that we embrace the idea of minimalism, which was already starting to be a common theme around that time when we started the project. We applied this idea not only to Create a Sim, but also to the other parts of the game, building houses and gameplay and online gallery, etc. And we tried to simplify the style and form. We looked at all aspects that would cause visual clutter and tried to minimize it or eliminate them completely. To that effect, we made the Sim the central part of all interactions. Clicking on the Sim is a starting point for most customizations. And extending this idea of clicking on a Sim was to allow manipulating the Sim by dragging on it directly, called direct manipulation. So to give some historical context, so on previous games, we provided a series of sliders to the users to customize the character. This is an example in Sims 3 to change the nose shape. With Sims 4, we added direct manipulation. That allowed the Sim's face or body to be customized by pulling and tugging directly on the Sim. To the user, this provides a feeling that they are actually sculpting or molding the model directly rather than playing with some sliders or UI widgets. We expose these controls, also known as hotspots, on the Sim's face as well as the body. And feedback we got from the users were very positive, and they liked the fact that you get immediate feedback to what they're doing, providing for a greater tactile experience. So how did we do this? So to enable this, we had a pick map that encoded various pickable regions on the Sim with a unique color value. So mouth value 100, nose tip 150, etc. Here on the top right, you can see the pick map wrapped around the Sim, and the UV map on the bottom left, and the unwrapped form of it, the bottom right, the way that artist authored it. As the user moves the cursor over the Sim, a render-based mouse picking system retrieves the color information from the pick map, and that maps to a region. From the region ID, we get the corresponding hotspot for that region, and the hotspot is like a resource that stores the highlights and the modifier that actually changes the geometry. This is an example of a highlight texture applied on the nose. And as the user moves the mouse, the drag delta is used to apply to the corresponding modifier values when we updated that. And the modifiers were created using bone poses, blend shapes, or deformation maps. And different hotspots became active depending on the view angle. And we call those pi wedges. So you can see that like you're manipulating the width of a nose. You want to actually do it in the front-on view, and nose length from the side, from the profile views, etc. We also did this for the zoom level. So if you're zoomed out all the way, you get to change the head shape at a gross level. Zoom in, the middle one lets you move the eye and do eye level changes, and then you zoom in further, you get greater detail and change the pupil or other eye details. And hotspot, as I mentioned, it actually stores the modifiers for X and Y axis. We didn't actually try to do it in 3D because all you have on a screen is a 2D, so we didn't try to include the depth in there. So depending on the view angle, you got that perspective and the modifiers. So, and the detail level, top, macro or micro level, the highlight texture, pi wedge that it applied to the region ID, which is actually the color value that I mentioned, and the cursor type, depending on the modification. And some of this in a code form, you can see that the cursor movement is finding out the pick result, which is actually we were using, again, this is a render pick method, which is maybe different from what some of the other games use. They actually can be doing the collision detection directly in the 3D space, but we used a render shader-based mouse picking. And you get the pick result. From that, you can get the region ID given a mode. And from that, you get the hotspot control. From there, you access the highlight texture, and you render it, push it to the shader, and blend it with the skin or the clothing. And depending on the mouse delta, you apply those changes to the modifier. And we did some optimization. Our Sims characters are very symmetric, or at least so far, which is the case that we didn't have to store the pick map for both sides. Just use half of that, right, saving on memory and disk footprint. We also added some resistance at the extremes, to give a more elastic feeling, and it provides feedback to the user when you reach the extreme by turning that into red, stuff like that, standard user experience. Also, the delta was scaled proportional to how much that modifier covered. So if it is a very small area, like a nostril adjuster, was more sensitive to mouse movement rather than an eye up and down movement. Moving on to another element that we added for creating interesting looking sims and making it more fun and accessible was smart randomization. And the idea of smart randomization is the ability to auto-generate sims that had a cohesive and consistent look. And these sims were not pre-generated. They were generated real time as you clicked on the randomize button and create a sim. Here are some more smart randomization in action. And you can see that each of them appeared to be wearing matching clothes that appeared to be coming from the same designer. Some male versions. And you can see some consistency in their style and their look. And that's not a surprise. We actually put in a lot of effort to expose that to the user. So how did we do this? Under the hood, it's heavily using a tagging system. We use the tagging system to assign attributes to different assets. So assets like pants and boots and tops and hair and skin tone, they were all given some attributes, like their age, gender appropriateness, their outfit type, their style, their color palette that they belong to, mainly for clothing, of course, their archetype, etc. And the randomizer basically threw a dice on these available tags and found the assets that match those, right? And if it fails to find the exact match, and then it uses a prioritization scheme to prune the tags and find the next best match, etc., until it found an exact match. And the system was used also for other purposes in the game. For example, gender switching. So the sim on the left, when you change the gender by clicking on the button and create a sim, you get a sim on the right. And you can see that there are attributes that are very similar, making them look like siblings or even a fraternal twin. Similarly, system in NPC generation, non-player character generation. So this is an in-game pizza delivery folks that they all look different, but they had the same outfit to make them look like they're doing a pizza delivery job, right? So it brings in more variety and not have to pre-author things. And we applied this in genetics as well to find the matching attributes from parents and give it to the children, in some cases from grandparents. So we skipped one generation, just like in real life. So you can see sometimes their eye color, their hair color, their hairstyle, the skin tone, they all try to match. And these are some of the postings from the fan sites. Last but not least, the fast response. This is having a fast response interactive experience is important for any interactive tool that we also put in, and for Sims games, it is especially important because of a few things. First of all, we tend to have our target audience with very low min-spec machines, laptops with no graphics card dedicated, and We have to be able to support a lot of customization in our games, right? Characters, the buildings, the terrain, etc. So pre-baking or pre-authoring things are not a way for Sims games. Not only that, we have a lot of Sims that show up on screen at the same time. And they may be changing their outfit as they are doing things. So building a sim quickly and rendering them fast is an important element. And you can see in this scene, like before they actually get into the pool, they change into the sim layer real time, right? And we did invest in some of the optimizations, like part instances that were lightweight, just the instance part were preloaded and organized by age, gender, and type for faster lookup. More heavier resources like the geometry, textures, and blend shapes, etc., were loaded on demand. Deformation maps were preloaded. I will get into the deformation map a little bit later. They are highly reused, so they were preloaded. Texture compositing was done in CPU. That's a deviation from how we did it on Sims 3. We found out that the readback from the hardware was prohibiting and was affecting some of the performance. So we went with CPU compositing. And that helped us scale it to lower-end min specs as well. And the textures were obviously DXT compressed, and on top of that, we used RLE compression to pack the pixels efficiently. So the other element, the other CoreX element about deeper level of customization, we introduced an idea called asset pairing. And this is the idea of mixing assets that shared the same physical space and resolving for any interpenetration, right? This is a classic problem with any 3D geometry that shares the same physical space. So one example is boots and pants. And you can see the bell-bottom pants and the combat boot put together, and the system resolves which one to show efficiently. And in previous games, we just worked around this problem by not providing for wider pants or boots, etc. And another example is combining hair with hat. So in this example, if a sim had a beehive hair, that shouldn't stop her from wearing a sun hat, should it? As you can see, the asset pairing helps resolve the interpenetration and figure out which part to show in an efficient way. And it's a generalized system. The runtime system doesn't know about whether it's a hair or a hat. In previous games we have tried to do that, but it can be a nightmare in maintaining that system. But this is a generalized system, and can be used for other customization systems as well. We just use that for characters. So this is an example of a pants combined with a variety of boots and shoes. So how do we achieve this? This is essentially dividing the character space into regions, right? And each region got a unique number. And additionally, each region had a layer value that you can assign depending on how much volume they covered. So a part with the greater volume will have a higher number, etc. And each asset was given a layer and a region ID. And the system goes through each region, and the part with the highest layer value wins. But if you were to use this brute force way that I just mentioned, there can be issues. For example, let's look at the boots combined with pants. Right? If you were to focus on the top part of the boots region and pick, in this case, the boots have the higher layer value, the boots will win. In the bottom, the pants have higher layer value, and that's not good, right, if you were to go with the... But how do we solve this? So We used a system called ripple effect system. Basically, it starts from the center of the sim, and if a part wins for that region, we actually keep that asset all the way down. So everything is good. The other thing we introduced was a facial customization system. So in Sims 4, we were able to provide for greater diversity in our Sims, how they looked, thanks to our new face customization system. And how did we create the faces and how we expose them to the users? They were put together using two building blocks, one archetypes and modifiers. Archetypes come with static mesh and texture. And you layer the modifier on top of it. So we call it texture wingman for a reason, right? So it's trying to bring in some of the details that we couldn't solve with just the geometry. And that provides for a greater variety in our Sims, how they looked. So here's an example of archetypes where on the left you can see the eye texture looks different, and the geometry obviously is different as well versus the one on the right. And the modifiers are applied on top. Here, one for the NOS modification. The modifiers were created using blend shapes or bone poses. Lastly, body deformations. On Sims 4, we had about 18 touch points on the Sims body that could be modified by the users. From neck to shoulders, to waist to belly, to thighs to feet, you name it. And these were primarily done using deformation maps. And some used bone poses. If we had a bone available that the animation was using, then we just used that to customize as well. But primarily deformation maps that I will get to. So you might be asking, why not blend shapes? Traditionally, a lot of these body changes were done using blend shapes. And so blend shapes, also known as morph targets, they're different terminologies, but blend shapes have a problem. They're strictly topology dependent. That means that if you're creating a heavy shape, blend shape for upper body, you can't actually use that for sim wearing a t-shirt or a jacket, for example. So you can see quickly that causes an asset explosion and causing memory and disk footprint issues. Also, blend shapes are great for doing it in hardware, but if you were to support older GPUs like DirectX, that runs DirectX 9, which was our case, you are limited by 4 blend shapes per vertex. That's because of the vertex input limitation, right? And they're not very extensible because you would actually, if you were to support a new body deformation, that would mean that all the assets that you shipped will need to be readjusted and have that blend shape added to it. So what is a deformation map and how did we benefit from it? Deformation maps store the delta mesh information just like in blend shape, but except it is stored in a RGB value in a bitmap. And these are inspired by the wrap deformers in Maya, if you know that, and displacement maps, but it's done in CPU. And they are largely topology independent. And they are quite extensible. So how do we author them? So you can see the neutral mesh on the left and the heavy fit and lean versions on the right. And that delta is calculated and stored in a map. So you can see the XYZ deltas are encoded as RGB values. And this is an example of a heavy shape for the upper body. This one is for the shoulder widening. And you can see there are a lot of areas that are empty or redundant. So we did put in some optimization to pack the data efficiently. One was the bounding box-based way to to identify where exactly that data exists, where the delta exists. And we did the RLE compression on top and used the vertical symmetry in this case as well. But deformation maps do have some caveats. One is that in this case, you can see the clothing actually is pinching in the middle. And that's because the DMAP created for an unclothed asset cannot map well to a loose-fitting clothing. So how do we solve this? We actually did have a separate DMAP for those types of assets. And in this case, you can see the red in the red area that we allowed the artist to paint and say, okay, these are the vertices that are loose-fitting, and then use the loose-fitting DMAP. And when you combine these two, you can see the results on the right. That actually looks right. And deformation maps have some additional requirements. They require additional UV set, and which we actually use for direct manipulation as well. And obviously, custom compression would be good because textures do take up more space than geometries in general. And that's it. Clearly, this is not one man's job. I would like to thank the awesome Sims 4 Create Sim team, especially Igor, Pavel, Glenn, Steve, Ken, and Jill. Thanks to you all for coming, and please fill out the electronic evaluation form at the end if you get a chance. I think we have a few minutes. All right, we'll take a few questions if you have any. Please come to the microphone. Thank you. Thank you.
Hi, curious about interpenetration issues that you guys encountered in terms of authoring animations for these sometimes drastically different models.
Sorry.
Yeah, did you guys just make sure that the animators would model animations that would work for all these different models, right, or was there some other support you guys had to do? So we did. So we tried to make sure that we didn't touch the ones that the animators were using, the controls. So like the blend shapes, for example, that done on the face, we actually layered the bone animations on top of it. So in theory, yes, they had tools to try out different levels of face customization, but in theory, we tried to keep it separate, right? What the animations touched versus what the face customization allowed them to do. Cool. And so then you must have just made sure that the animators, when they make a walk animation, that the arm just would naturally pass far enough away that if they're fat or thin, it doesn't. That's a good point. Actually, I didn't actually talk about that. We did have a slotting system that, depending on the shape of the sim, they adjusted. So slotting that the animation looked at. So if it's a heavy shape, the arms actually moved outward. So you didn't see any interpenetration caused by the animation on those. And then that was all procedurally done? Like
yes.
The animators didn't even have to worry about it?
Exactly, okay. Procedurally.
Hi, I just had two quick questions. The first one about the hotspot maps.
Yeah.
On the artist's authorization of that, is that just done in Photoshop, like a spec map?
Photoshop.
Okay.
Exactly.
Great. And then also, how are you guys storing and deserializing your tag information? Is it you guys using your own format, or using JSON or XML? Or?
It's a custom format. We have binary resource that packs the data. But essentially, we have an editor that lets you tag things efficiently, and then we pack that data in a binary form.
Sorry, one more question, quick. And most of your tools for authorization are like in Maya, or do you guys try to use this? Do designers in anything ever use this tool, or do you guys, this is the end user always? I've always wondered about a tool that a designer could use. Maybe it has some functions that are debug
not
mode.
Exposed to the user?
Yes.
Yeah, I mean, Maya was used for authoring assets, but then we have this, the proprietary tools that we use to allow tagging and things like that. That was not done in Maya, right? So you bring in those assets, and then you tag them appropriately using these tools. And yes, they were not exposed to the users. And yeah, we did invest in custom tools for those purposes.
All right, thank you very much.
Sure. Welcome. Hello.
2 questions. How did you QA this? There's a lot of,
I know, right?
variability there.
Yeah. Glad you asked. Yeah, QA, software quality engineering, that we invest quite a lot on those mainly because the game itself is non-linear, right? There is no real path that every user takes. And not only that, you can customize a whole bunch of things. So we did have to write a lot of test scripts and automation scripts that, the building testing into the software that we build was an important part that we invested quite a lot in. So we would test, any changes would be run with these scripts and see if there are issues that come up.
Run the permutations, and then somebody's got to take a look at it and say, this looks
exactly.
okay.
Yeah, we had real-time charts that were displayed and, that people could go and look at and see if there are issues introduced and zoom in on that build and try to figure out what went wrong. So, yeah. It is slightly different from, I've worked on a Medal of Honor, type of game where things are much more controlled, right? And pre-authored and pre-baked, and this is a different type of game, yeah.
Also, are your meshes all rigidly scaled?
I think you're out of time. Okay. One more, maybe? Quickly.
Does the deformation map needs... Deformation map needs vertex texture fetch.
What is the what?
Vertex texture fetching in shader code.
What is the...
in the shader code.
What is the shader code?
When you're rendering the mesh.
When you're rendering the mesh?
Vertex shader. And then you load the deformation map. Does it need the feature of the vertex texture fetching?
What is texture fetching?
Vertex.